So now we're going to be looking at other indeterminate forms. And the most common kind you're going to get to, there's a few different kinds of indeterminate forms. The most common kind where we're going to have either 1 to the infinity, infinity to the 0, or 0 to the 0 limits. Now we're still going to do L'Hopital's rules, but we basically have to do a conversion to make it look like a standard 0 over 0 or infinity over infinity. Okay, and the trick for the exponential ones is we're going to apply an e and a natural log. And that will allow us to turn it into, to use the natural log properties to sort of simplify it. So let's take a look at some of the examples of doing something like that. So if I plug in x equals 0 to this first one, I'm going to get 1 to the 1 over 0, some kind of infinity, 1 to the infinity, which is like, a non-determinate form. So instead what we do is we basically say, well, we're going to do the limit as x goes to 0 of e to the natural log of x plus 1 to the 1 over x. And we do this because e to the natural log is allowable to do because they just negate each other, right? And we do this because we can put the 1 over x in front. Because that's the properties of natural log, right? Is you can move anything in the exponent gets to pop out in front here. And that becomes limit as x approaches 0. E to the ln of x plus 1 over x. Now, if you look at this guy here, he is a kind of fraction. If you plug in 0, it's ln of 1, which is 0, over 0. So this guy up here, so we can technically the formal way you do it is you could say, I can make the limit just of this inner function. And then I'm going to use L'Hopital's rule on this guy in here because he is a 0 over 0. So limit x approaches 0, derivative of that is 1 over x plus 1, then just over 1. And then when you plug in 0, you get 1 over 1, which is 1, so you get e to the 1, which is just e. Okay? So that's the trick for that. You're basically still doing L'Hopital's rule, but you have to do some manipulations first before you can apply to get into that 0 over 0 or infinity over infinity indeterminate form. Let's look at this one. 0 from the right, it's 0 to the 0, okay? So the 0 to the 0 is also one of those indeterminate forms. So you're going to make it, limit x approaches 0 from the right, e to the natural log of x to the 2x. Then I can put the 2x in front. Now, if you were to plug that into here, this would be 0 times ln of 0 from the right, which is negative infinity. And when you get one of those, what you're supposed to do is move 1 to the denominator. Now, in practice, we usually leave the natural log alone and move the x down to make it 1 over x. In that way, when I plug in 0 to the right here, this guy becomes infinity because ln of 0, natural log, as you approach 0, it goes to negative infinity, and 1 over 0 from the right is positive infinity. So that's an infinity over infinity. So we say using L'Hopital's rule, that's the same as the limit as x approaches 0 from the right, e to the 2 times 1 over x, and then this be negative 1 over x squared. Right? And then you can, instead of writing like that, you can make that x squared over 1, multiply it by the reciprocal, and then you can see the x's are going to cancel. And so this would be the limit x approaches 0 from the right, e to the negative, because I still have a negative sign here, negative 2x. Okay, and then that's just e to the 0, and then e to the 0 is 1. Okay, let's take a look at this one here. All right, same thing. Take the limit x approaches 0 from the right, e to the natural log of x to the 1 over cosine of x. Okay, well, let's plug it in first. It's going to be 0 to the 1 over cosine of 0 is 1, 0 to the 1 power. Actually, I think 0 to the 1 is not an indeterminate form. I actually don't think you need to do a trick for that one, because this one you can just plug in. You're going to get 0 to the 1 over cosine of 0, right, which is 0 to the 1, and 0 to the 1 is just 0. Okay, so that one, you actually don't need to do the trick or L'Hopital's rule because it's not an indeterminate form. How about this one? When I plug in 0, I'm going to get 1 to the 0, and 1 to the 0 is, I'm pretty sure it's just 1, right? It's not one of the indeterminate forms. So again, this is fine. This would just be 1 to the 0, which is just 1. Because 1 to the anything is 1, even to the 0th power. Okay. How about this one? Now it's infinity. Actually, sorry. I don't know what I'm thinking. This is not, I don't know what I'm doing. When I plug in 0 here, it's 1 over 0, it's infinity. It's negative infinity to the 0. That is an indeterminate form. So my mistake on that one. So I have to write it. I thought I was doing something wrong there. Ln of 1 minus 1 over x to the x, and then I'll bring the x in front. Oh, e to the x ln 1 minus 1 over x. Some people just focus on this limit and then do the e later. That's certainly fine. It's just, it saves you a little bit on writing. But I would like to, since I'm teaching you guys, I kind of want you to do everything. Now, I never recommend moving the natural log to the bottom because that would make the derivative really annoying. So instead of times x, you make it over 1 over x, right? That's the idea. You can move it to the denominator. And that way, when I put in the fraction here, this is going to be ln of positive. That's infinity over infinity, basically. So that is a indeterminate form where we can just use L'Hopital's rule, where I'm going to take the derivative of the top guy and the derivative of the bottom guy. So the top guy is going to be 1 over 1 minus 1 over x. Then by chain rule, the derivative of negative 1 over x is 1 over x squared. And then, let me put the e there. And then derivative of 1 over x is negative 1 over x squared. And so some things can happen is this 1 over x squared cancels with that 1 over x squared. And I still have a minus sign. So it becomes e to the negative 1 over 1 minus 1 over 0 to the left. 0 to the left makes that infinity. 1 over infinity is 0. Right? So it becomes e to the 0, which is 1. Okay. Let's take a look at this one. This is infinity. So when I plug it in, I get 1 minus 1 over infinity, which is 0, to the infinity power. That is an indeterminate form. So we're going to do the limit x goes to infinity, e to the natural log, 1 minus 1 over x to the x, right? Move the exponent in front. Hopefully your old hat's at this point. Just kind of a standard process we go through. And then we move the x onto the denominator. It's actually almost just like the last one, I'm pretty sure. Was there no difference in this one? Yeah, it's the exact same function. So all the algebra, we'll just do it again just to, as practice. Move the 1 over x on the bottom. Then we're going to use L'Hopital's rule to make it limit x goes to infinity, e to the 1 over 1 minus 1 over x. Then by chain rule, derivative of 1 minus negative 1 over x is 1 over x squared, over negative 1 over x squared. The 1 over x squareds cancel. And then you're pretty much plugging in infinity. So it's e to the negative 1 over, because I have this minus sign down here, 1 minus 1 over infinity. It's not really the right thing, but that guy's going to go to 0. So it just becomes e to the negative 1, which is 1 over e.